last data we need to take is the acceleration of the wooden disc when we hand this 100 mass on its side. Okay, to do that, we are going to start a program called Logger Pro. That's our data taking program. So I'll type LOC Logger Pro. In fact, all I did was type in L. So start this one, and you need to open the file. It's in physics with Vernier. Actually, it's not in physics with Vernier, sorry. It's in PhotoGates, probes and the sensors. Probes and sensors, pulleys, PhotoGates, because it's a file called the pulley. So it can measure distance. Oh, we have not connected the sensor yet, so let's connect the sensor. That's our smart pulley. We need to undo our string. It's the string we're going to hang it and put the smart pulley on. There are two rubber stoppers. So remove one of them, put it in here. And these two rubber stoppers, they can hold the smart pulley in position. Push them so relatively tight. Put our wooden wheel on. Let's see, connect the other end of the smart pulley to the interface box. Once it's connected, we can check if it's working by hitting the collect button. And then, can you show that? And turn this pulley by hand and look, oh yeah, it's taking data. So that's good. The velocity slows down because it's friction, okay? All right, so everything is working. We can drop our mass now. So, first acceleration. I'm going to tape this beginning of the string to where this one is, number 1. Then wrap it around the wooden wheel, wooden disc, and hand the 100 mass to the other end. So we are all ready to go, okay? Start the program and let the mass drop. You have to wait about 3 seconds. I'm going to hit collect and count 1, 2, 3, 4, 5, drop. Stop it. Okay. Now we see our data. Okay, you can see look at the velocity. That's what we are interested in. There is a part that is increasing very nicely until it hit the floor, and it's no longer increasing, it's decreasing. So this slope is the acceleration that we are looking for. First, you can guess how big should it be. Is it 9.81? Well, if you drop that mass without any burden to its tail, it's going to be 9.1. But now it has to drag that big wheel after it, so it will be much less than 9.81. I'll zoom in so that we can see it better. Yeah, I see it's increased very nicely. So select the part that is increasing linearly and use the button, linear fit. There's several buttons, but choose the button where you see linear fit and click on that. The graph rescale itself, but that's okay. So we have this slope of velocity graph. Our first acceleration is, read this number, 2.495 meter per second per second. So we got our first acceleration. Very good. Okay, we just need to repeat this process for 2 more times. Each time we are going to move the starting point about a third of the wheel. So start 120 degrees away from that number 1 and hang our mass to the end. That's our second acceleration. Cross the smart pulley, hold it there, click, collect, wait, 1, 2, 3, 4, 5, short. After it hits the ground, you can stop it. Try to get the second slope. Well, we don't need the first slope, we need this slope, linear fit, and here is our second slope. Okay, that's good enough. All right, so the last one, we wrap it again, and this time we're going to move it 120 degrees more to this side of the number 1. And grab it and hand the mass to the end. Cross the pulley, hold it there, hold, wheel, collect, 1, 2, 3, 4, 5. Okay, so we got our third reading, third acceleration. Select the part that was linearly increasing and get the linear fit, will show its slope. Okay, so we got 3 accelerations. Use the scatter as the uncertainty. Let's finish our data taking.